Welcome back to the ABAGY Robotics Welding Lab. Today, we're going to do something different.
Hi, Richard.
Demetrius.
I have a special thing for you today.
Okay, what are you on?
I have a bucket.
Oh.
And we're going to weld it today.
Bucket day. That's a fine big bucket.
Yes.
How much does it weigh?
About more than 100 kilos at least.
Aha.
We're gonna start from placing it on the table. And we have a new table today.
Perforated table.
Okay guys, we need to put it on the table. Are you ready for hard work, Richard? No?
So, what's the task?
We have fixed it, placed it on the table, and we are going to weld it. But before, I will explain to you why it is not so easy. We will start from description of the bucket itself.
Yeah.
This is a blade. This is a front blade. We have two side blades, and as you see, they're from different material, because this is the part of the bucket which hits the ground or something with the most strength. Okay, that is why its thickness is greater and the material is greater. It's high strength material, and this is mild steel. Okay. So actually, you have tons of different types of buckets for different special needs. For example, you have a trenching bucket, you have a V-shaped bucket, you have a special digging bucket, you have a skeleton bucket, which is used for when you have some mix of different materials. You want to put in the bucket on the big parts. And remove smaller parts.
And what you call this one?
This is an ordinary digging bucket. Yeah, but we don't have teeth here. So you need to attach teeth here.
They're good?
So-called ears.
Ears?
Yes. Can you see them?
You got these ears, brilliant. Okay.
Yes. And they are also from different material. And we will have three types of legs, sizes of legs of weld. Okay, the biggest part will, the biggest leg will be with the thickest material here.
This?
Yes.
Okay.
And the other parts will have smallest leg. Okay, let me show you the task on the in ABAGY software.
All right, so load it up. It works with gloves.
Yes, because you have some oxide, because they're dirty on them. Yep.
Okay, what are we gonna select?
I believe the template for the task is already prepared here in our software. We may just click and weld. But before that, I want to show you some problems we might have if we would say it would have less functionality. For example, with this weld, this is a tricky weld because you don't have and I have perpendicular plates here. That is why you need to rely on some adjacent plates. Let me show you. So this will have manual touching points. If you remember, we use touch sensing in order to understand if the curvature of the weld is different from the ideal one.
Yep. And
here we use multiple touching points.
Yeah, that green.
Yes.
Very good.
You see, this bucket is relatively small.
Yeah.
In reality, you may have like large buckets. This bucket is small and it's suitable for this type of cell. With this positioner, with this robot. And but if you have a larger one, you will need just larger positioner and the robot.
Yep.
Let me show you another difficulty. Come here. As you see, these plates do not touch. They do not touch each other. You see? Some 3 millimeters there. And that is why we will need 2 passes in order to fill the gap with the metal with the first pass and then cover it with another. So the scanning is done, and now we need to make sure that the part is not that different from the model.
Yes.
Click on the red button.
Red button.
Yes.
Lovely. Green is good.
Green is good.
Yeah.
Green is good. And you also see that our vision has detected fixtures. Okay? So it will not touch them by nozzle accidentally.
Yeah. That's nice.
Everything is pretty green, so I believe that we may start welding. We need to cover it with aluminium just for the heat from the welding will not break the inner calibration of the tool. So actually, as this is a laboratory, we don't have the good guard for the heat, automatic. So usually in production we have an automatic solution for that, but just right here we need to have some like manual thing.
Wait a minute. How can it see through the? It can't see through the foil anymore. It cannot see through the foil.
Yeah. So as we already have ended the scanning, that is why we don't need this anymore for this weld. But it will weld for more than 1 hour. So we want to make the device safe.
it's looking great. Nice seams, yes?
Yes.
Right, let's talk, yeah.
Yes.
We've got thick.
They're very nice.
We got good thick ones here, yeah?
Yeah, yes, 2 passes here.
Yeah. And it's good in the corners.
The craters are good.
Brilliant.
These so-called overlapping seams also good.
Yeah, these aren't flush, the metal.
Yeah, they're not perpendicular, like they're like this one and this one, this plate.
But now
slightly
it's
overlap.
very nice. So can you use it straight away, or do you need time for the seams to like dry or cool down? Or
I believe it's already cool enough.
Yeah.
We may paint it.
Paint it.
And use it. That's all.
Use it.
No. We need to add some manual labor here for these smaller welds because of these ones. Because the torch just may not go in this narrow.
Yeah, there's
position.
only 2 centimeters here.
Yeah.
So okay. So this took 2 hours to do.
About 2 hours. Yes.
And it would take.
It would take about 2 weeks to program it with the positioner, for the touch sensing to be programmed with each pendant.
Right.
Yes, that is why like it's a game changer with robots. With robots, it's really can be done in reasonable time.
And we have this guy just finished, and right down there we've got 2 more. So this is low
volume, high mix.
Low volume, high mix.
Yeah.
It's great. Thanks. Let's see you next time.
Bye bye.